Okay, now we're going to talk about covalent bonding. So ionic bonding was when electrons are lost and gained. Covalent bonding is when our electrons are shared by atoms to form bonds, also known as a covalent bond. So we have different types of electrons. We have bonding pairs and what we call lone pairs. Bonding pairs are what make a bond between two atoms. Lone pairs are a pair of electrons that are not part of a bond. So water, for example, has two bonding pairs. So this would be one, this would be the other, and then it has two lone pairs. All right, there's three different types of covalent bonds that can be formed. That is a single covalent bond, a double covalent bond, and a triple covalent bond. We'll start with the single. A single covalent bond is when two atoms share one pair of electrons. Okay, and so we actually see that here with water. So this here between the hydrogen and the oxygen, they're sharing one pair of electrons. And I can draw that too with a single line. So I can draw that bonding pair just like that. Then I see the same thing here. One pair of electrons are being shared between oxygen and this hydrogen. And again, I can represent that as a single line as well. The single line represents one pair of electrons being shared between these two atoms and these two atoms. And then I still have left over a lone pair here and a lone pair here. Okay. One thing to know is that hydrogen can only form a single covalent bond. Okay, a double covalent bond, this actually exists between two oxygens. So oxygen's a diatomic molecule. There's two of them put together. They're bonded with two pairs of electrons in between these two oxygens. Two pair of electrons represents a double bond. And we can represent that with a double line. There's still two lone pairs around each of our oxygens. Now, what does this represent? There's 8 electrons around each oxygen. 2, 4, 6, 8. 2, 4, 6, 8. So we're going to be using these electrons and pairing them up and still following the octet rule. Sulfur would be the same thing here. So then we have a triple covalent bond. Nitrogen bonded to itself has 3 pairs of electrons in between the two. And so we call that a triple covalent bond. We can also represent that here with 3 lines. So these two nitrogens are bonded to each other with a triple bond. Actually, let's go back real quick here. And then just a side note, there are 8 electrons around each nitrogen. 2, 4, 6, 8. 2, 4, 6, 8. All right, so with covalent bonding, Lewis theory tells us that we should have 8. Now there's some exceptions. Hydrogen can never have 8. It's only going to share a pair of electrons. It's always just going to have one single covalent bond. The same is true because of the halogens. Halogens have 7 valence electrons. They only need 1. They're only going to make 1 bond. Oxygen generally forms either 2 single bonds or a double bond in its molecular compounds. All right. So we'll come back to this and drawing these in a different chapter. Right now we're going to continue to talk about our molecular compounds, which are put together by covalent bonds, and how we name them and write out their formulas. Now, Molecular compounds, again, are composed of two or more nonmetals. So those nonmetals can be in different quantities. So we have to find a way to name them appropriately. And what I mean by that is if you were to take all of these right here, right? If we were to name them like we named our ionic compounds, the first one would hold its elemental name, and the second one would end in "ide." So this would be nitrogen oxide. This would be the same thing, same with this, and they're all very different compounds. So we have to have a way to differentiate them. So when we name our molecular compounds, here we go. We're going to write the name of the element with the smallest group number first. If the two elements lie in the same group, then write the element with the greatest row number first. Then we're going to give them prefixes. So our subscripts will give with a prefix. And here are your prefixes. 1 is mono, 2 is di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Now, the first, and this is how we're going to do it. You're going to name the prefix and the first element holding its elemental name, then the prefix of the second element, and it, like ionic compounds, is going to end in "ide." Now, if your prefix is 1 for your first element, you do not include it. For example, all right, let's look here. First, I need to recognize that it's a molecular compound, so 2 nonmetals. So I'm going to name it. I have a 1 here, so I don't need my mono prefix. So A is going to be nitrogen. And then I have a 3, so that's tri iodide. Okay. This one is going to be phosphorus. 5 is penta, so phosphorus pentachloride. Pentachloride. All right. Here we have a prefix. It's not 1, so it's 4. That's tetra. So you're going to have tetra phosphorus deca sulfide. Tetra phosphorus deca sulfide. Here, dinitrogen penta oxide. Dinitrogen penta oxide. Here, I'm going to write it as it's written. So phosphorus is P, and then tri is 3. So I have 3 bromides. PBr3.